Hello. Now we are going to look at some problem-solving questions involving calculus, where we are asked to find the maximum values of different functions. And often we have to create those functions in these types of questions. So we can be given a story and we have to connect that story to some formula that we know or that we're given. And sometimes we also have to connect it to a visual, like a rectangle in one of the examples we're going to do here. So the general advice would be write down any formula that's given to you. Say in our second question, I'm given a height formula here. I'd write it down on my page and see if I could do anything with it. Or do I know any formulas? In our first example here, I'm going to be talking about a rectangle. What formulas do I know for a rectangle? And second, if I'm told about a shape in the question, I want to draw a very quick basic sketch of that shape and label all of the information I know about its sides or its area or stuff like that, so that I have more context for the information I'm given. Beyond that, let's go into our examples. So we're told the perimeter of a rectangle is 24 meters. Find the area of the rectangle in terms of one of the side lengths. So I'm told I'm dealing with the perimeter of a rectangle. I'm going to follow my advice here and I'm going to draw a very quick basic sketch of a rectangle. So I'm dealing with the first part. How do I write the area in terms of one of the side lengths? Just to give myself a feel for what it is I'm talking about, I'm going to draw a picture of a rectangle. Don't know what the shape actually is, but that looks roughly like a rectangle. And I know that rectangles have lengths and widths. So what else do I know? Well, I know that's also the width and that's also the length. And I know the perimeter is 24. And I'm asked for the area. So what's the area of a rectangle? I write down the formula for that. That's the length by the width. And I also know the perimeter is adding up all of the side lengths together. And that's supposed to add up to 24. So I could say the perimeter is equal to the length plus the width plus the length plus the width, and that's equal to 24. Now, I haven't tried to answer the question just yet, or I haven't gotten into the meat of trying to answer the question just yet. All I'm doing is telling myself what the question told me. I was told I was dealing with a rectangle, so I drew one. I labeled all of the sides that I know in terms of how I normally describe a rectangle. I'm asked about the area, so I write down the area formula for a rectangle. I'm told about the perimeter, so I write that down. The perimeter is 24. And then I took my picture and I said, well, I know what the perimeter means. It adds up all the side lengths, and that should be equal to 24. So I've done all of that just telling myself what I was told in the question. And we have to have the confidence to be able to do that. Now that we've done that, can we make progress towards what we've been asked for? Well, if I look at what I was asked for, I want to find the area in terms of one side length. And at the moment, I have the area in terms of two side lengths. The length and the width are the two side lengths for my rectangle. So how could I use the other information I've got to try and write this in terms of one of my sides, either the length or the width? Well, the only other equation, the only other information I've got is this equation here. The perimeter must add up to 24. So let's just tidy up this equation and see if we can get anywhere. I have some like terms here. So I have some lengths and I have two widths. So I can add them up together. So I'd have 2 lengths plus 2 widths should add up to 24. Well, if I look at this equation now that I've simplified it, I have length and width in this equation. If I got the width by itself, I'd be able to sub it into this equation here for the area, and then I'd only have an equation involving L, involving the length. Well, that would be what I would be looking for, the area in terms of one side length. So I'm going to use this formula here to try and sub into this one to get what I want. So I'm going to get the width by itself. So I have 2L plus 2W should be equal to, or is equal to, 24. I'm going to try and get the length by itself. So I don't want, or get the width, I should say, by itself. So I'm going to get the length out of there. I'm going to get the width would be equal to 24 minus 2L. I want to know what one width is, so I need to divide by 2. So the width of my rectangle would be divide both of these by 2, so I'd end up with 12 minus L. So the width of my rectangle must be 12 minus L. Well, that means that I can sub that description of the width into this area formula. The area is going to be equal to the length times the width, which is the length times the width in terms of L, would be that. So I end up with, multiply out my bracket, I have L groups of both of these things, so 12L minus L by L is L squared. So the area in terms of one of my side lengths is 12L minus L squared. It was the first thing that I was asked to do. That's the end of part 1. I have the length is one of my side, L is one of my side lengths, and that's describing the area of my rectangle. So now I'm asked to find the maximum area. Well, if I want the maximum of something, I know the maximum happens when I have stuff like dy dx is equal to 0, and then the second derivative would be negative for a maximum. But I'm not dealing with x and y here, I'm dealing with a and L. So instead of getting dy dx is equal to 0, I'm going to have to get dA dL. A is where y would normally be, and L is where x would normally be. So I'm getting dA dL. I'm getting the derivative of A as L changes. So what would that be? I'd just get my derivative as normal, so it'd be 12. This is L to the power of 1. 1 on L to the 1 minus 1 minus, I don't really need that bracket there, but you can put 1 if you like, 2L to the 2 minus 1. Maybe more comfortable with it, so we'll put it in brackets. So we have 12 L to the 1 minus 1, it would be L to the 0, which is just 1, so that's going to be 12 by 1, minus 2L to the 1, so that's just 12 minus 2L. So I want to know when the maximum happens, and I know that that's when my slope formula, my rate of change formula, is equal to 0, so I need to make that equal to 0. So dA dL has to be equal to 0. 12 minus 2L has to end up being equal to 0. So I rearrange my equation and I will get my value for L. So I want L by itself, I don't want that 12 there, so minus 2L is equal to minus 12, divide both sides by minus 2. Minus 2 divided by minus 2 is 1. I now have 1 of L is equal to 6. So that is going to be the length that I'm looking for. I have to justify that that is a maximum, so I need to get the second derivative. I'm going to do that over here. I'm going to get the second derivative, d2a dl squared, and that's just getting the derivative of this. So I'm going to write it out. You're just taking the derivative again. When we do out our derivative, you're just using power rule again, we get minus 2. We don't get a letter involved here because this is just a quadratic equation. So we don't end up with a letter in our second derivative, but it's negative. So that tells us we have to be going to the top of a hill. The slope is becoming more negative. If we graph this function, it would have a top of a hill to it. So we have minus 2 for our rate of change of our slope everywhere. So we know that this is going to be where we get a maximum, because that's all we get out of this quadratic. There's no minimum. So what we need to do now is, we weren't asked for the side length, we were asked for the area. So now I need to go back and say, well, the area is equal to the length times the width, or I know that the area is equal to 12L minus L squared. So I could find the width using this formula here and then multiply the two of them together, or I could sub into my area equation just involving the length. Either will work. So the more general case because we could be asked for the dimensions of the box. So in general, what I'm going to do is find the length, or sorry, find the width, and then multiply the two of them. But we could just sub 6 in for our L here, and that would work perfectly as well. We have 12 minus L. We know L is 6, so the width is 6. Now this may not particularly surprise us. The maximum area of a rectangle happens when the rectangle ends up being a square, if there aren't other restrictions involved. We end up with 6 times 6 is 36 meters squared. So that's the maximum area. So a ball is thrown upwards. Its height above the ground is 50t minus 5t squared. When did the ball land? Well, when it landed, its height above the ground would be 0. At ground level, the height above the ground is 0. So for our ball, we want to know when was the height 0. So 50t minus 5t squared has to be equal to 0. I have a common factor of 5t. I'm just solving a quadratic equation now, but I can see I have a common factor. That's how I'm going to do it. So minus t is equal to 0. So I rearrange that. 5t could be equal to 0, or 10 minus t could be equal to 0. Divide both sides by 5. So t could be equal to 0, or rearranging, minus t equals minus 10. Divide both sides by 1, minus 1 I should say, and t would be equal to 10. So t is 0 is not a wrong solution, but that's probably where the ball got thrown into the air in the first place. So when t is 0 is at the start, so the ball was at ground level when it got thrown up. So the ball being at ground level at the start when t is 0 makes sense. So the time we're interested in is after 10 seconds. I'm going to say that this is in seconds. After 10 seconds, the ball hits the ground again. So that would be the answer we would be interested in. How long was the ball in the air? That is fairly straightforward. It's just going to be after 10 seconds it lands. It started it was left the ground at time is 0. So it was in the air, I should say, for 10 seconds. That can be more complicated, but here it's pretty straightforward. What was the maximum height reached by the ball? Well, the maximum is going to be when dh dt is equal to 0. So we're going to get that derivative. And when we use our power rule, we get dh dt would be 50 minus 10t. Now we need to find our value for t, so we solve that equation. We just get t is equal to find our time that our maximum height happened at. When we do our rearrangement, t is equal to 5, and that would be 5 seconds as I'm interpreting it. To find the height, we would then sub that into our height equation. When we sub that in and put it into our calculators, we get the maximum height reached by the ball was 125 meters, and we'd need to show that we proved that it was a maximum by getting the second derivative and showing that it was negative. When we get our second derivative, we find that we get minus 10. Again, this is a quadratic equation, so it doesn't end up with a value for t involved in the second derivative, but it is negative. That means the slope is becoming more negative as we read left to right. That means that we must be going over the top of a hill, so we have a maximum. So that's how we can use our calculus to find the maximum values of different functions. And that's what we need for now.